Morning, fifth grade. Welcome to lesson 6 in math. Hopefully you got your power up done already. You notice it's a new power up. Because it's a new power up, I'm going to read the answers on the front side this first time, and then when you get to other power up B's, you'll go and I'll correct them myself. But I want to make sure you hear my thinking and what's going on with that. So it's missing numbers, and my thinking goes like this. Missing an addition, I should subtract. 20 minus 12 is 8. Missing the first in subtraction, I add. 8 plus 10 is 18. Missing in multiplication, divide. 40 divided by 5 is 8. Missing the dividend, I multiply. 12 times 4 is 48. Missing an addition, subtract. 24 minus 11 is 13. Next row. Missing the second, still subtract. 25 minus 10 is 15. Missing in multiplication, divide. 60 divided by 10 is 6. Missing the divisor, divide. 24 divided by 6 is 4. Now they kind of wrote it backwards, guys, but it's still an addition problem. We say j plus 8 equals 15. Missing an addition, you subtract. You get 7. K minus 5 equals 20. So I'm missing the first number in a subtraction problem. I add those together. So 5 plus 20 is 25. Those are a little tricky when they write the answer on the other side. Third row. Missing a multiplication, divide. 30 divided by 6 is 5. Missing the dividend, multiply. 9 times 3 is 27. Missing an addition, subtract. 18 minus 6 is 12. Missing the second in subtraction, still subtract. 15 minus 5 is 10. Missing a multiplication, divide. 36 divided by 4 is 9. Final row. Missing the divisor, I still divide. 16 divided by 2 is 8. Missing an addition, subtract. 12 minus 8 is 4. Missing the first, add. 30 plus 15 is 45. Missing a multiplication, divide. 48 divided by 8 is 6. And missing the dividend, multiply. 6 times 3 is 18. Okay, so you got your answers now. As you work these things in the future, if you need to go back to these, feel free to, but we want to make sure we got our thinking right. It's great practice to do those every single day. Okay, I'm going to go through problem solving with you. Hopefully you got the mental math one done already. Keep working on those things. And then notice the little mark they made by letter H. Letter H, they got the little 1 by it, and it just says, as a shorthand, we will use commas to separate operations to be formed sequentially from left to right. This is not how you write math. So normally, we have order of operations we're going to talk about this year, where I always multiply and divide before I add and subtract. They're saying we're just going to put commas in here. We want you to work left to right in these problems. That's not how you're supposed to write math, but they're going to do it anyways. The problem solving says this: the sum of 5 different single-digit natural numbers is 30. The product of those same 5 numbers is 2,520. 2 of the numbers are 1 and 8. What are the other 3 numbers? So 6, I wrote on the board here, I have 1 plus 8 plus I don't know what those 3 numbers are equals 30. When I multiply them, I got 1 times 8 plus I don't know what those 3 numbers are equals 2,520. Now what I do know is they're single digit and they're all different, so I can't use 1 or 8 again. So I started right here and said it ends in 0. To end in 0, I need one of these numbers to be a 5. So I stuck a 5 in here. I also then said, hey, we're using the same numbers on the top and the bottom, so I stuck a 5 in there. Now I got 2 choices. I could multiply and then divide to see what this might be, or I could add and then subtract. I'm going to choose addition because I think it's a little bit easier for me. 1 plus 8 is 9, plus 5 is 14. So I'm going to take 30 minus 14 and get an answer of 16. Now the question is, what 2 numbers add up to 16? Well, 8 and 8 does, but I can't use an 8 yet. They have to be different. So my only other choice is 7 and 9. Because I could have used 4 and 12, but 12 is not a single digit, guys. So the only single digit ones is 7 and 9. Boom, got my answer. So they said, what are the other 3 numbers to use? You should have had 5, 7, and 9. You could have done 1 times 8 times 5 got 40. Divided by 40, you would have got an answer of 63. And then you could have said, hey, what 2 numbers give me 63? 7 and 9. It's a great problem leading up to what we're going to talk about today, guys. And what we're talking about today is factors and divisibility. And there's a lot of fun problems that come off of this. Hopefully you got your yellow folder ready to rock. Very few things to fill in, but a beautiful chart that's going to give us a lot of helpful hints. I'll get rolling. It says this: Recall that factors are numbers multiplied to form a product. 3 times 5 is 15, 3 and 5 are factors of 15. 1 times 15 is 15, so 1 and 15 are factors. Therefore, each of the numbers, 1, 3, 5, and 15, are factors of 15. Notice that 15 can be divided by 1, 3, 5, and 15 without a remainder. This leads us to another definition of a factor. Factors of numbers are whole numbers that are divided the number without a remainder. Now that's your blank in your yellow folder. What a factor is, it doesn't have a remainder, guys. For example, the numbers 1, 2, 5, and 10 are factors of 10 because each divides 10 without a remainder. That is, the remainder is 0. So 1 goes into 10 10 times, 2 goes into 10 5 times, 5 goes into 10 2 times, 10 goes into 10 1 time. All right, let's see what they're going to make us do. Example number 1 says, please list the whole numbers that are factors of 12. So I got 12 up here on the board, and some of you do it this way. I'm going to start with 1. 1 times what gives me 12? 12. I'll move to the next one. It's even. 2 times what gives me 12? 6. And 3 times what gives me 12? 4. So my factors are 1, 12, 2, 6, 3, 4. Good answer. Okay? Some of you like to put things in order. You feel free to put things in order. You do not have to, guys. It doesn't matter how you write those things. Either way, you got to have these 6 together. Example 2 says, list the factors of 51. Well, I know 1 and 51. Lots of us will say, we're done. And we're going to learn on the next page that we're not done because 1 plus 5 is 6. If 3 goes into 6, then 3 goes into 51. So I'm going to quick divide that because I don't know how many times 3 goes into 51. It goes in there once, subtract, bring down, 7. So I have factors of 3 and 17. Not a common one, guys, and so be careful. We'll learn those divisibility rules coming up. But now we have our 4 factors. That leads us to what we're going to talk about with greatest common factor in between those 2 paragraphs, or 2 examples. From the first 2 examples, we see that 12 and 51 have 2 common factors. 1 and 3 are in both of those lists. The greatest common factor then of 5 and 51 would be 3 because it's the largest common factor. They abbreviate that GCF, guys. You're going to have that abbreviation a lot. And then we'll get ourselves to the challenge of keeping that straight with least common multiple in a number of lessons when we get to that one. We'll practice that one once. It says find the greatest common factor of 18 and 30. So step 1, what I need to do is list all the factors of 18. I'm going to challenge myself to put them in order. So I have 1, I have 2, I have 3. Now I'm going to find their partners. 3 goes with 6, 2 goes with 9, 1 goes with 18. Same thing with 30. 1, 2, 3, 5 with 6, 33 with 10, 2 with 15, and 1 with 30. You don't have to go in order, but if you can pull off order, then it's really easy. Now they asked me for just the greatest common factor. You see common, you see common, you see common, and you see common. The biggest one then is what we choose, and the greatest common factor between 18 and 30 is the number 6. They love these problems, saying what's the greatest common factor between 2 numbers, because it makes you do all this factor work, like example 1 and example 2, with just one question between them. Okay, at the bottom of the page, we saw in example 2 that 51 can be divided by 3. The capability of a whole number to be divided by another whole number with no remainder is called the divisibility. Thus, 51 is divisible by 3. There are several methods for testing the divisibility of a number without actually dividing. Listed below are the methods for testing whether a number is divisible by 2, 3, 4, 5, 6, 8, 9, or 10. Here are the rules. The number is divisible by 2 if the last digit is even. The number is divisible by 4 if the last 2 digits can be divided by 4. The number is divisible by 8 if the last 3 digits can be divided by 8. So what they're going to give you guys, they're going to give you really big numbers. And I'm just going to write down a really big number. 12,345. So what they're saying is to see if it goes into, if it's divisible by 2, you just look at the last one. So to see if it's divisible by 4, you look at the last 2. To see if it's divisible by 8, you look at the last 3. Okay, now they give me a problem that's just 88. Okay, to do that one, guys, there's no 3 digits, so I just have to divide by 8. I just have to divide by 4. So sometimes it's not a shortcut if the number's smaller. But when they give you bigger numbers, I only have to do the last 3 for 8, the last 2 for 4, and the last 1 for 2. 5, it has to end in 0 or 5, 10 has to end in 0. 3, it says if I take the sum of the digits and it can be divided by 3, then it's in there. That was 51. 1 plus 5 is 6, it's in there. For this one, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. Adds up to 15, 3 goes into 15, so 3 would go into that one. Number 9 is the same rule. This added up to 15, 9 would not go in there because it doesn't add up to 15. Okay, so I have a number 702. 7 plus 2 is 9, therefore 3 will go into this number and 9 will go into this number. Guys, because 3 goes into 9, anytime you have a 9 listed, you have a 3 listed, but it's not true the other way around. This one was divisible by 3, but not 9. But if this one's divisible by 9, it's also divisible by 3. The last one they give you is the number 6. 6 you don't have to do any work. If you start an order and say, 1, does 2 go in here? Yes or no? 2 doesn't go into this one, 6 won't go into it. So for 6 to go in there, 2 and 3 both have to be listed already. Okay? Now guys, if it's an odd number, no even number can go into it. I don't need to check 4, I don't need to check 6, and I don't need to check 8. The answer is always no. Even numbers only go into even numbers. So keep that in mind. Use that reference guide, and then if you notice something, guys, the number 7 is missing. Now, there is a clue, a hint for 7 that you could look up on Google. It's kind of complicated. I usually just think it's just easier to divide. But what you're going to have to do is to say, does 7 go into this number? I have no idea. The only way I know is by actually doing that division to be able to figure it out. We'll show what it works like in example 4. It says, which numbers from 1 to 10 go into 9,060? And so what I want you to do, guys, is listen to how I do this in my brain. I'm going to list all the numbers from 1 to 10 that go in there. 1 goes into it because 1 goes into everything. 2 goes into it because it's an even number. 3 goes into it because 9 plus 6 is 15. Lots of times the first thing I do when I get to a big number in a problem like this, I do the addition and I just write it down. 3 goes into 15, 3 is there. Now 4 says check the last 2. So I say, does 4 go into 60? Some of you might know that in your head. Some of you might have to quit, do the math. I did the math. 4 goes into 6 once, subtracted 2, 20, goes in there 5, 4 goes in there evenly 15 times, 4 is in it. Does 5 go into it? Yes, it ends in 0. Does 6 go into it? Yes, because 2 and 3 are already here. Does 7 go into it? Most of us go, nope, because it doesn't look right. Guys, that's not a choice. You can't go with looks and math. So I literally have to say, I'm going to divide by 7. Now, 7 goes into 9 once, 7, subtract 2, bring down a 0. 7 goes into 20 twice, gives me a 14. Subtract gives me a 6, bring down another 6. Goes in there 9 times, 63, bring down the 3. Last one brings down the 0. 7 does not go into 30 evenly, 7's out. 8 says, look at the last 3 digits. So that is 060. So does 8 go into 60? Nope, no 8. Does 9 go in there? When I add them together, I got 15. Does 9 go into 15? Nope, 9's out. Last one is 10, ends in 0, gets an answer of 10. 1, 2, 3, 4, 5, 6, and 10. Once again, when you look at example 4, guys, it's such an easily worded problem for the book. Hey, just check these things, and yet there's a lot of work for us to be able to work through all 10 of those numbers and see those in there. Now, guys are going to about 50% with the number 7. Lots of times they're going to give you that number 7 and you're going to say, no, 7 doesn't go in there. And a lot of the numbers they pick will have 7 going into it just because they know you have to do the math to be able to get that answer. And so that's the divisibility rules. That chart on your yellow folder, guys, man, I would memorize that thing. Hopefully you already have it memorized, but keep working to make sure you have those. Check your practice set for extra practice if you need to work with that stuff, and then we'll be on to the 15 problems out of our assignment. All right, 6, here comes our problem set from lesson 6. We'll start with number 2. It says list all the common factors of 30 and 40. So the first thing I do is 30 equals 1, 2, 3, no 4, 5, 6. 3 went with 10, 2 went with 15, 1 goes with 30. Do it again with 40. 1, 2, 4, 5, 8, 10, 20, 40. Now for letter A, it says list all the ones that are in the same one. So I got 1 and 2. I have 5 and 10. Check it over, that's all of them. So A, 1, 2, 5, 10. B says what's the greatest? So for, this is A. For B, it's the biggest number here, would be 10. So you can start to see a short question, decent amount of work. Number 4 says use digits to write 407 million. So step 1, 407, comma, 6,000. No 100, no tens, 6,000. 962, 962. Number 5, list all the whole numbers from 1 to 10 that are divisors of 12,300. So I'm just going to write down 12,300, and I want to go like this. Number 1 is 1 because 1 goes into everything. 2 is there because it's even. 1 plus 2 plus 3 is 6. 3 goes into 6, so 3 goes into that number. Check the last 2. 4 goes into 100, so 4 goes into that. Ends in 0 or 5, so I get a 5. 2 and 3 are part of it, so 6 is part of it. To do 7, I have to do the division. Okay, so I'm going to rewrite it because I didn't give myself enough room up there. And so I have 12,300 divided by 7. Goes once, 7, subtract 53. Goes in there 7 times, which is a 49, gets a 45. That's really sloppy, sorry. Goes in there 6 times, gets a 42, which is 30. Doesn't go in there, boom, no 7. 8 says look at the last 3. So I grab just the 300 and I divide it by 8. Goes into here 3 times is a 24. That's a 60. 8 doesn't go into 60. 8's out. 1, 2, 3 is 6. So 9 is out. Ends in 0, so 10 is in. So my list of single-digit whole numbers from 1 to 10 is 1, 2, 3, 4, 5, 6, 10. Number 7. It says the number 3, 4, 5, 6 is divided by which single-digit numbers? So same problem that we just did. This time we're doing 3,456. So I'm writing over here 3,456. 1 goes into all of them. It's even. 2 goes into it. 3 plus 4 is 7. Plus 5 is 12. Plus 6 is 18. 3 goes into 18. 3 goes into this one. Next one, divide by 4 is the last 2 digits. So I got 56 divided by 4 goes in there 14 times. 4 is in. 5 doesn't end in 5 or 0. It's out. 6 is in because if 2 and 3 are in, 6 is an automatic. 7, I need to check. 7 goes into 34. 4 times. That's a 28. Subtract. Can't do. 65, that goes in there. 9 is a 63. 26 doesn't go in there. 7's out. 8 is the last 3 digits. So I have a new math problem, but I have to do it because I don't know it off the top of my head. 8 goes into 45 5 times. That's 40. Subtract is 5. 8 goes into 56, so 8 is in. 9, remember when we added this, we got 18. 9 goes into 18, so 9 will go into this one. So for number 7, we have 1, 2, 3, 4, 6, 8, 9. Great problems, checking our divisibility. Number 9 says write this in expanded form. 6 is in the thousands position, plus 4 is in the hundreds position. The rest are zeros. Problem solved. Number 12, letter next to a number means multiply. To solve it, I divide. So I'm taking $50 and I'm dividing it by 8. 8 goes into 56 times. That's 48. Subtract, bring the 2 down. Subtract, get a 2, bring the 0 down. That goes in there
twice is 16. Get a 4, bring the 0 down, goes in there 5 times. It was money. So I got an answer of $6.25. Number 13, missing a number in addition. So we have to do multiplication, but first we have a big, huge line of addition. So I have 7 plus 4 plus 8. I have 6 plus 2 plus 1. I have 6, 8, 9. Some of you might look for pairs to 10 or 20 or 15s, things that are a little bit easier. I'm just going to work straight down. 11, 19, 25, 26, 27, 28, 34, 42, 51. Add it all up, I got 51. Now I got to take that answer and I got to subtract it from 60. Get an answer of 9. Turn your answer key over. We got number 16. In number 16, I'm missing the dividend on the top. When you're missing the dividend, it means you multiply. So I have 32 times 8. 16, carry the 1, 24 plus 1 is 25, gives me a 256. Number 19, big subtraction problem, $100 minus 48.37. So that becomes 99, that becomes a 9, that becomes a 10. 3, 6, decimal point, 1, 5. Bring my dollar sign down, $51.63. Number 22, dots mean multiply. So I have 7 times 11, gives me 77. I'm going to take 77 times 13. Gives me 21, carry the 2, 21, 22, 23. Add a 0, 77. Put them together, 1, 0, carry, 10. So I got 1,001 when I'm done with the multiplication. 23, big division problem. I have 43,271 being divided by 9. 9 goes into 43 4 times, that's 36. Subtract. 13 minus 6 is 7. Bring down the 2. 9 goes into 72 8 times, that's a 72. Subtract 0. Bring down a 7. It goes in there 0 times. 7 minus 0 is 7. Bring down the 1. Goes in there 7 times is 63. Subtract, get an 8. So sorry, that's a really sloppy 7. I have 4,807, remainder 8. Okay, so don't forget the remainder. I think that's the first time this year we had a division problem that gave us a remainder with it. Number 24, adding problems, they have them all set up differently. So I have $14. I have $8.49, and I have just 48 cents. So we got it all set up right, having to add the 2 zeros and then the decimal point for the bottom 0 if you want that. Add together is 17, carry the 1, 4, 4, 1 is 9, decimal point straight down. 8 and 4 is 12, carry the 1, 1 and 1 is 2, dollar sign, $22.97. Number 25. Has parentheses, which means do it first. Step 1, 430 minus 58. Cross out the 3, make it a 2. 10 minus 8 is 2. Cross out the 4, make it a 3. 12 minus 5 is 7. 3 minus nothing is 3. I then take my answer and subtract it from 1,000. So I have 1,000 minus 372. 10 minus 2 is 8, 9 minus 7 is 2, 9 minus 3 is 6. I get an answer of 628 overall. Number 26, parentheses next to each other means multiply. I'm going to do 16 times 140. 0 goes straight down. Sometimes that's helpful, sometimes it's not, but we go like this. 4 times 6 is 24, carry the 2. 4 times 1 is 1 plus 2 is 6. This 0 had carried down, so I add a 0 for the tens place. 1, 6, add, and get 2,240. Last but not least is number 30. Number 30, they said you have 8 times 7 times 5. And they're going to teach you how to do this problem, hopefully in your head. The next thing they did is they said you have 8 times 7 times 5, and they switched what was in parentheses. They said we're going to do that one first. We're going to group it different. Anytime you change parentheses, you have the associative property. Then they're going to do 8 times 5 times 7. The same numbers are in parentheses, guys. They just switched the order. That's commutative property. And they said, let's do 8 times 5 times 7. And let's put different numbers in parentheses. They're back to the associative property. Then they said, can you do 8 times 5 in your head and get 40, and 40 times 7 in your head to get 280? So associative to commutative to associative, kind of too many steps, but they're trying to show you that you can, just making you recognize those different properties that we keep practicing.